to Science Fantastic with Professor Michio Kaku. Every week on Science Fantastic, we profile some of the most amazing developments in science and technology, science that affects your life, maybe even changes your view of the universe. Well, today we're going to bring on a very controversial topic. The former chairman of the astronomy department at Harvard University has written a best-selling book called Extraterrestrial, the first sign of intelligent life outside the Earth. That's right, the first sign of intelligent life outside the Earth. Are there alien civilizations out there in outer space? Well, we'll find out from AVI Loeb, former chairman of the astronomy department at Harvard University, and we're going to talk about this strange extraterrestrial object, an object from another solar system that drifted through our solar system in 2017, creating a storm of controversy. Was this a piece of interstellar debris, an asteroid, a piece of space junk, a comet, a meteor, whatever? Or was it a machine, a device created by an extraterrestrial civilization? Well, we'll talk about that in today's hour. But today, we're going to talk about a different topic. We're going to talk to the former chairman of the astronomy department at Harvard University, Professor AVI Loeb, about an object from another solar system that drifted through our solar system in 2017, creating a storm of controversy. Was it a piece of space junk, a piece of space debris just drifting in outer space, designed by an extraterrestrial civilization? So, Avi, glad you could be on Science Fantastic.
Thank you for having me.
First question for you is, when you were a youth, think back when you were a kid, what steered you in the direction of science and then eventually astronomy?
I was mostly interested in philosophy. I grew up on a farm, collected eggs every afternoon, felt very connected with nature, and was interested mostly in philosophical questions. I used to drive the tractor to the hills of the village on weekends and read philosophy books, mainly existentialists, because that was very appealing to me, to deal with the most significant questions we have. You know, we are born into this world without a script. We are standing on a stage and we don't know the meaning of that. And philosophy tries to address that. As Socrates said, philosophy is preparation for death, so to speak. We want to figure out before we die what we are here for. But then in Israel, where I was born, you have to serve in the military at age 18, and I had two options, either to run in the fields with a gun or to pursue some intellectual research and in the context of physics and mathematics. And so I did the latter because it was closer to philosophy. And then I initiated a project that was funded by the Star Wars initiative from the U.S., and that brought me to Washington on a routine basis. And I visited in one of the trips, I visited Princeton and was offered a 5-year fellowship at the Institute for Advanced Study under the condition that I'll switch to astrophysics. So I ended up eventually, after that long-term fellowship, I ended up at a junior faculty position at Harvard. And by the time I got tenured a few years later, I realized that I'm actually, even though it was an arranged marriage, I'm actually married to my true love. Because in philosophy, you can address deep philosophical questions. In astronomy, sorry. You can address deep philosophical questions that were in the realm of philosophy, but we can address them with scientific tools.
Okay, so what steered you in the direction of astronomy? And then, of course, talk to us about what happened in 2017 when this mysterious object drifted through our solar system from another solar system.
Right. So most of my research in astronomy focused on the first stars in the universe, the first light that was produced by stars, and then black holes. And then in 2017, I heard about this object called Oumuamua, which means in Hawaiian scout, because it was discovered by a telescope called the Transtars on Mount Haleakala in Maui. And this was the first object from outside the solar system that was spotted near Earth. And it's sort of like finding the first object from the street in your backyard. And it tells you something about the street, even without making a trip to see what's out there. And I was curious because I wrote a decade earlier, I wrote a paper saying that we will never find an object like that from interstellar space with a Pan-STARRS telescope based on what we know on rocks in the solar system. How many of them are being lost to interstellar space and so forth. So that was the mere discovery of this object was a surprise, but then astronomers thought, well, it must be a comet. Turns out that there was no cometary tail, didn't have any gas around it, looked very peculiar. Then it exhibited a change in its brightness that was a factor of 10 as it was tumbling over 8 hours. And that implied a very extreme shape, that it's at least 10 times longer than it is wide, projected on the sky, because what we see is reflected sunlight. And as it's tumbling, it means that the area on the sky changes by a factor of 10. And actually the best fit model to that variation of the light was that of a pancake-shaped object, not cigar-shaped. So here you have it, the pancake-shaped object, and then in addition doesn't show any cometary tail, but nevertheless it showed one other peculiarity, which is being pushed away from the sun. And that usually can come from the rocket effect of evaporated gas.
Avi, we have to take a short commercial break. Welcome back to Science Fantastic with Professor Michio Kaku. As we said before, our special guest today is the former chairman of the astronomy department at Harvard University, Professor AVI Loeb, author of an exciting but controversial book called Extraterrestrial, the first sign of intelligent life outside the Earth. Now, some of you out there may believe that there are alien civilizations in outer space, but as Professor Carl Sagan once said, extraordinary claims require extraordinary proof. Well, in 2017, this mysterious object, an object from outside the solar system, drifted through our solar system and left a trail of controversy. Was it a piece of space debris? Was it a piece of rock just drifting in space, tumbling as it went through? Or was it a sign of extraterrestrial civilization? So with us today, once again, is AVI Loeb. The book is called Extraterrestrial, the first sign of intelligent life outside the Earth. Well, Avi, we have Newton's law of gravity, and using Newtonian mechanics, we can plot the trajectory of objects going all the way out past the solar system, into the galaxy, in fact. So did this object obey Newton's laws of gravity? Was it a piece of drifting rock just tumbling as it went through our solar system? What was the trajectory of this object?
Yeah, so actually the trajectory deviated from what we expect just based on the sun's gravity. And that was one of the anomalies that it exhibited. And it wasn't because of the rocket effect. It wasn't because gas was evaporating out of it, pushing it forward. It was something else. And the only possible explanation was that the reflection of sunlight is giving it an extra push. And actually the force varied in a way consistent with this possibility. It was declining inversely with distance squared in a smooth way away from the sun. And actually just a few months ago, in September 2020, there was a new object discovered, and the astronomers gave it a name 2020 SO. Turns out it was showing also a push away from the sun by reflecting sunlight and no cometary tail, and it was identified as a rocket booster that was launched in 1966. So we know that we produced it artificially. The question is, who produced Oumuamua?
Well, what was the evidence that clinched it for you that this was extraterrestrial rather than a piece of space junk? What was the most convincing piece of scientific evidence?
It was the fact that it was pushed away from the sun without a cometary tail and without any gases around it. So the Spitzer Space Telescope looked very deeply for carbon-based molecules. And in order to get that push, it needed to lose at least 10% of its mass. Quite a bit of mass. We should have seen it. We haven't seen it. So that was the thing that convinced me that, we should list all the anomalies of Oumuamua, and there are 6 of them. I mentioned a few. There is another one that it came from a special frame of reference, the local standard of rest, where only 1 in 500 stars is so much at rest as Oumuamua was, and that's a very weird property. But there were lots of anomalies, 6 of them, that I decided to summarize, and then it looked to me like there is a strong case that it might not be a natural object. And in the couple of years after my paper appeared, there were a few attempts to explain it as a natural object, but all of them invoked something that we have never seen before, like, for example, a hydrogen iceberg, which suffers. I mean, the idea is that the evaporation of hydrogen will create a cometary tail that we cannot see. It's transparent. But the problem with that is that such an iceberg would get evaporated along its journey. It wouldn't survive. We wrote a paper about that. Then there was the idea of a cloud of dust that is very porous, 100 times less dense than air. And again, the problem with that is it wouldn't survive coming close to the sun and getting heated by hundreds of degrees. So my point is, if all the natural origin explanations bring up something that we have never seen before, why not contemplate an artificial origin?
Okay, well, let me be devil's advocate for a while and throw some other things out that you've probably already considered. What about anomalies in the solar wind, or perhaps a debris of micro-asteroids that cannot be seen by telescope that impacted on the object? So could there be interactions with the interstellar medium in terms of the solar wind, in terms of space debris, a trail of microasteroids that could have caused this anomalous trajectory that seems to deviate from Newton's laws of gravity?
Yeah, these are excellent questions, and I actually thought about them first. Before we wrote the paper, I checked the numbers exactly along the lines that you're asking. Turns out that the effect of the solar wind and any material along the path is negligible. It's much smaller than the effect of per unit area, than the effect of the illumination by sunlight. So the only other thing that competes with sunlight is evaporation, the rocket effect, but we didn't see any evaporation around it.
Okay, now you propose that perhaps it's a solar sail created by a civilization that, rides on the solar wind. So tell us a little bit about the breakthrough Starshot program that the late Stephen Hawking proposed and promoted, the idea that perhaps tiny solar sails can reach the stars. So explain your involvement now with the breakthrough Starshot program.
Yeah, so actually, a light sail is just like a sail, except it's not being pushed by wind, but it's pushed by reflecting light. And the story starts in 2015 when Uri Miller, an entrepreneur from Silicon Valley, came out of a black limousine near the Center for Astrophysics at Harvard and entered my office and asked me whether I'm willing to lead a project to visit the nearest star so that the trip will take only 20 years instead of 50,000 years if we were to use conventional rockets. And I said I have to look at the technologies that can enable that. He wanted to see the visit within his lifetime. And the only thing that made it possible is a light sail, where you push a sail with light, a very powerful laser beam. So 6 months later, I proposed that to him. And then we invited Stephen Hawking, as you mentioned, to the public announcement of the project. And this is called Starshot. The idea is to use a laser beam of 100 gigawatts focused on a sail that has roughly the size of a person outside the atmosphere and weighs a few grams, and push it for a few minutes to a fifth of the speed of light so that it can reach the nearest star, Proxima Centauri, within 20 years.
Okay, so we're talking now about Earthlings reaching the stars with a solar sail pushed by laser light. Now turn the tables. Do you think that Oumuamua could therefore be a solar sail from another civilization using the same principle to boost its starships, perhaps through our solar system? What are your thoughts?
So that would explain the excess push that it exhibited along its orbit. It needs to be thin, and nature doesn't produce sails like that. Now, it doesn't need to be designed as a sail. It just needs to be thin enough so that it has a lot of area for its weight. And this rocket booster that I mentioned was just like that. It was hollow and had a very thin surface. So anything like, for example, if you imagine a surface of a spaceship being ripped apart, it would still exhibit the push from reflecting sunlight, even if it was not designed for that purpose.
Okay. Now, of course, any extraordinary statement is going to create an extraordinary backlash. What has been the reaction from your colleagues and the astronomical community to your theory, which certainly deviates from the usual statements issued by scientists? What's been the reaction?
That's right. The reaction was dismissal or pushback or denial. To me, I approached it as a kid. Let's put all possibilities on the table. Let's see what is possible in terms of explaining these anomalies that we have seen. I don't care about the consequences. I just want to see what possibilities are available and then collect as much evidence as possible. Now, for Oumuamua, we can't get more evidence, but in the future there will be more objects discovered of this class.
Welcome back to Science Fantastic with Professor Michio Kaku. We're talking about the possibility that perhaps we have been visited by an extraterrestrial object which sailed through our solar system back in 2017. The book is called Extraterrestrial, the first sign of intelligent life outside the Earth. Well, once again, we're talking to Professor AVI Loeb, former chairman of the astronomy department at Harvard University. Let me ask you a question that you've probably already been asked many times, and that is the giggle factor. When you talk to scientists about aliens from outer space, people roll their eyes up to the heavens and they start to giggle. Have you hit the giggle factor, and what do you do when people challenge you and say this is the stuff of science fiction?
Well, it's very simple to deal with that. All you need is to collect evidence, because science is based on evidence. And in this case, just to give you an example, we just need to deploy cameras within the orbit of the Earth around the Sun and take a close-up photo of the next object that looks as weird as Oumuamua. And that photo will tell us whether it's a rock or an artificial object. A picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book. I wouldn't need to write the book if I had a picture.
Okay. Now, what was the strongest argument against your theory, and how do you respond to that? So of all the arguments that have been raised, what do you think is the strongest argument, and how do you refute it?
Yeah, so the strongest argument was extraordinary claim requires extraordinary evidence. And my point is, no, it's enough to have anomalies that you need to attend to, because they are, scientific facts. There were measurements that provided results that do not quite line up with the type of objects that we have seen. So we need to put all possibilities on the table and not dismiss, not say it's never aliens, because it could be. So my point is, we should be open-minded, and that should motivate us to get more evidence, rather than us saying we don't want to discuss this possibility whatsoever. Because imagine if anatomy was dismissed just because people said the human body has a soul.
Welcome Welcome back to Science Fantastic. Once again, we're talking about extraterrestrial civilizations in outer space. Have we already been visited? We have with us today the former chairman of the astronomy department at Harvard University, author of the book, Extraterrestrial, the first sign of intelligent life outside the Earth. So, Avi, let's say you're right, and this object is from another civilization, an advanced civilization. What is it doing in our solar system? Is it doing reconnaissance? Is it simply a piece of space debris left over from their space program? Is it piloted? Are there aliens on this object? What are your thoughts, assuming that you're right?
Yes, that's an excellent question. And of course, we want more evidence, more data, more clues. But what we know is that it was tumbling. It was not in full control of its behavior, dynamical behavior. So to me, that illustrates that it's probably a piece of junk, space trash that, most likely billions of years old. If you imagine, most stars formed before the sun, billions of years before the sun, and if they had civilizations that developed equipment, this equipment that was floated into space, like Voyager 1, Voyager 2, New Horizons by us, it's by now billions of years old, and therefore it's not functional anymore. It's just like finding a plastic bottle on the beach that is punctured, has holes in it. It's not really useful for anything, but you can tell that it's not a rock. So my guess is probably something like that. But then there was this peculiar fact about Oumuamua that it came from a special frame of reference, the so-called local standard of rest. Only 1 in 500 stars is so much at rest in that frame. It's the frame that you get to when you average over the motions of all the stars in the neighborhood of the sun. It's sort of like the galactic parking lot. And this object was at rest there. So the sun just bumped into it like a giant ship bumping into a buoy on the surface of an ocean. And the question is, is there a meaning to that? Does it mean that maybe there are lots of buoys that serve, for example, like a grid of coordinates that interstellar navigation is guided by? Or maybe it's relay stations for communication. We don't know. We just need to find more evidence about objects of the same type.
Okay, and in your book you talk about perhaps a new science is being created called Archaeoastronomy. That sounds like a contradiction in terms. What is Archaeoastronomy?
Right. So in the past we searched for radio signals as a sign of extraterrestrial intelligence, and that is equivalent to trying to speak on the phone with someone. You need that someone, that counterpart, to be alive. But on the other hand, for example, we can't have a conversation with the Mayan culture. The culture is not around anymore. It's dead. So how do we know that they existed? We find relics in an archaeological dig. And so we can do the same thing in space. If we find relics of civilizations that existed billions of years ago, we would know that they existed. It's a completely different method of finding evidence. Rather than listening for radio signals, we should do space archaeology, search for relics left over, billions of years ago by other civilizations in space.
Okay. Well, there's been other flashes in the news concerning the possibility of extraterrestrial intelligence in space. For example, we have Tabby star. Some people think that the fact that light from a star diminished by, 50% or so? I forgot the exact number.
Yeah,
indicates that, maybe that there's a Dyson sphere that's been sucking energy away from a star, which would, of course, require a civilization thousands of years more advanced than us. So what are your thoughts about Tabby star and whether that could be an example of archaeoastronomy?
Yeah, so there are various ways of searching for technological signatures. You can search for industrial pollution in the atmospheres of planets. You can search for artificial light. For example, the city of Tokyo can be seen by the Hubble Space Telescope all the way out to the outskirts of the solar system. On Pluto, if we had on Pluto a Tokyo-like city, we could see it with the Hubble Space Telescope. You can search for structures, like you just mentioned, the Dyson sphere around a star. But I think, well, first of all, the engineering requirements for a Dyson sphere or some big object.
Okay, Avi, we have to take another short commercial break. But after the break, we're going to continue a discussion of your book, Extraterrestrial, the first sign of intelligent life outside the Earth. Back to Science Fantastic with Professor Michio Kaku. Once again, our special guest today is the former chairman of the astronomy department at Harvard University. The book is called Extraterrestrial, the first sign of intelligent life outside the Earth. So, Avi, we were talking about, well, the SETI project. We've had a number of people from the SETI project on the air talking about eavesdropping on radio signals from extraterrestrial civilizations. But some of these civilizations, as you pointed out, may be dead. They may be ancient, in which case we should look for relics from these civilizations. And you're talking about a new science called Archaeoastronomy, looking for evidence of extraterrestrial civilizations, some civilizations that may no longer be alive. So could you elaborate on that?
Right. So most stars formed before the sun, and billions of years earlier. The sun is a relative latecomer, and if they had civilizations similar to ours that produced probes similar to New Horizons, Voyager 1, Voyager 2, or a lot of other equipment that was sent out of their solar system, then these would fill up the interstellar space, and we could see those messages in bottles, every now and then. And the point is that we are summing over a history of billions of years of the Milky Way galaxy rather than relying on a civilization being around today to communicate with us. And that offers a much richer setup for finding evidence. And it has nothing to do with the Drake equation that is often used, because all you care about is how many objects you have per unit volume. Sort of like if you walk on the beach and you want to ask, what is my chance of encountering a plastic bottle? It just depends on the number of plastic bottles per unit area on the beach. And in the case of space, it's per unit volume. And we should not make a guess. We should just go out and search. And a simple way to search is place cameras within the orbit of the Earth around the sun. And whenever such an object comes close, take a photograph and try to figure out is it a plastic bottle or is it a rock. Very simple.
Okay. Now, also, the Hubble Space Telescope is gradually going to be superseded by the Webb telescope, which looks into the infrared region of the spectrum. And do you think, therefore, that we're going to be able to actually one day maybe photograph one of these extrasolar planets and gain more evidence as to what's out there? The fact that perhaps life may be more common than we thought in the galaxy. What are your thoughts?
Well, first of all, we now know from the Kepler satellite that of over half of all sun-like stars, 50% plus or minus 30, have a planet the size of the Earth, roughly at the same separation. And to me, that implies not only that we are not at the center of the universe as Aristotle postulated, our backyard is also not very unusual. There are lots of Earth-Sun systems out there. And therefore, I think it's very likely that if you arrange for similar circumstances, you get similar outcomes. After several decades of working in astronomy, I developed a sense of modesty. That's the biggest message you get. You are not privileged in any way. You are not special. You're not unique. You're not at the center of the universe. You're not. Your environment is not unusual, and that implies to me that life as we see on Earth must have existed in many other places. And perhaps even we are not the smartest kid on the block. We are not the sharpest cookie in the jar. And that would be a sense of modesty that, my daughters, when they were young, they spent their time at home. They thought that they're the smartest. And then they went to the kindergarten, got a better perspective. There are smarter kids with better qualities. We need to mature as a civilization by finding others.
So how do you answer the question, or maybe you have already, the Fermi paradox? If the galaxy is teeming with advanced civilizations, then where are they? How come they haven't visited us? Did they go into extinction or some sort? What are your thoughts?
Yeah, I think this question is very arrogant, because when I met my wife, she had friends that used to say that they're waiting for Prince Charming on a white horse that will make them a marriage proposal. And that never happened. So us saying, where is everybody? Why don't they come here and have a party with us? Why don't they spy on us? Because, we are probably not sufficiently interesting. We are probably like ants on a sidewalk. There are lots of them, and nobody pays attention to a specific ant. And why would we even think that we should easily see them nearby? I think that, nobody cares about us, probably. That's the modest point of view. We should get used to that.
Okay. And let me ask you a hypothetical question. Nikolai Kardashev, a famous Russian astronomer, had a classification of advanced civilizations, type 1, type 2, type 3, based on energy generation. Type 1 would be planetary. They absorb all the light coming from the sun. Type 2 would be stellar. They basically harness the energy of an entire star. And then there's type 3, galactic, which is the energy of an entire galaxy. And then he calculated how long it would take for civilizations to go from type 1, 2, and 3. And then, of course, Carl Sagan then estimated that on this cosmic scale, we are type 0, actually type 0.7. So we're just children when it comes to this galactic scale of energy consumption. So what are your thoughts?
Yes, of course, we are just at the beginning. We have 100 years or so of modern technology, and our technology is evolving very fast over a few years time scale. So imagine what our technology would be in 1,000 years or in 1,000,000 years. And that's why we can have a shortcut. If we find the civilization that had those 1,000,000 years, we can borrow some of those technologies. It would feel like cheating in an exam, looking over the shoulder of the student next to you. But if we save 1,000,000 years in the process, it's worth it. And you can make a lot of money out of it.
Okay. Well, thank you so much for being on Science Fantastic.